Power over Ethernet's been around for quite some time. It's gone through an evolution where it started as Ethernet and just providing a little bit of power that's used for voice over IP phones and things, and then gradually gone from more about 15 watts over a power over Ethernet line to 30, 60, and now they go all the way up to just under 100 over just a simple power over Ethernet line. And then LEDs, they've also progressed over the number of years, and as we all know here, pretty much a standard. So don't even have to really talk too much about that. We're all using them. You see them everywhere. So both of those things have pretty well commercialized. And once again, power over Ethernet going through its evolution. So you're seeing things that pretty much everything, I believe, above the waist is going to become DC. And so power over Ethernet not only has DC power, but also that data. So it makes it really simple, plug and play, to be able to attach all kinds of different devices, whether it's IP cameras, IP Wi-Fi access points, whatever you can imagine, or hasn't even been conceived of yet. So by having that greater power capability, now that really continues to open up the opportunities. And we're really at this perfect storm where you have what's called efficacy, which is how many lumens you get per watt. So lights using less power, getting more power over Ethernet, and then having the smart building and the power over Ethernet lighting being, that software-defined network, bringing it together so that you can have something that the lighting is just at the beginning. It's just, if you want a smart building, what better thing to use than lights? Because it's everywhere. And so if you want to attach nearby sensors or actuators, you just go to a nearby light and attach to it, versus any other infrastructure, let's say the heating, ventilation, air conditioning, or whatever, that's buried in the back of the building. There's not as many endpoints available. So it becomes a fantastic infrastructure and fabric for a smart building. So if we look at different things that power over Ethernet can do that are kind of the game changers, one of those being you can now use Platinum-rated switches. So Cisco in particular has a Platinum-rated switch. So that works really well for smart buildings, particularly if you're doing retrofits. You can just put a switch just about anywhere and now be able to go attach to that nearby lights, sensors, whatever you want. And then, obviously with lighting, it's a life safety issue. So that has very unique use cases, lots of requirements, which we've had to go through a lot of certification with UL and with all the other certifications, because we're worldwide, so we're in 27 different countries, we're CE approved as well. But just with UL in particular, there's, I think, about 5 different certifications we have, including 924, which is for emergency lighting. We also have a patent on the emergency lighting, so that we're really, we've been told by Cisco and Hubble that we are the way of doing a centralized backup. So imagine being able to use a UPS that is then attached to your switches, that then if it needs emergency power, the UPS is what's powering these lights. So you don't have to have batteries in every single fixture, which batteries only last so long, just like your cell phone or anything else. They don't last so long. So you don't want to have to go around replacing batteries all the time in your facility. Instead, it's in one centralized location, and it makes it a very simple thing to maintain. Ultimately, we can automate the reporting and diagnostics so that, and you're supposed to, be doing monthly testing and annual testing and things. So that opens up the door to be a lot more intelligent about that. In today's world, you have an occupancy sensor, and typically you'll have 3 occupancy sensors because they'll be going to different systems and they're siloed systems. But ideally, we want that one occupancy sensor to be used for all of them. So what we want to do is have a building system network where that one occupancy sensor can flow its data to all those systems rather than being a silo, individual silos for these systems. So when you then expand that out, you can see how you can have daylight sensor, occupancy, temperature, VLC, all these different types of functions that may be cross-platform, cross-cutting between these different systems. Well, now you don't have to have those silos and come up with strange integrations that take, they're very custom, for instance, and time-consuming to build. Instead, those sensors can sit directly on the same network and then just be shared to those individual automations that are for lighting or for security or whatever it is. So this is an example of a floor plan where these are individual lights. So these are 2x2 troffers. And this particular one has, let's see, an occupancy sensor, that's a CO2 sensor, VLC. So each one can have, you don't have to have all the same sensors on each fixture. In a lot of cases with today's technology, you have, let's say, a daylight sensor on every single fixture because the daylight sensor is sending so much data that over typical, let's say, wireless systems, it's just too much data. You can't handle it. Wireless systems aren't meant for that. So you have to have a sensor on every single fixture and it providing that localized information and its own intelligence locally versus being able to put one daylight sensor along a wall near windows and then zone that entire area and share that information and then be able to respond very, very quickly. So as everyone probably already knows, the sensors are the eyes and ears of the system, but then because of the flexible nature of this, it also allows for being able to expand the system easily and flexibly, not just today, but in the future. So imagine you have all these PoE connections, it's a standard, it's only gaining standardization and market adoption. We're also getting into being able to communicate with the node, which I'll get into in just a little bit, over serial bus and connecting analog systems and even USB devices. So just imagine being able to connect just about anything, anywhere, and not have to run new cables and do a lot of new labor and complex engineering and design to be able to continue to expand your system over time. On the scalability aspect, the really nice thing about Power over Ethernet is that pretty much at any scale it makes sense. So you see, these are the various different devices. You have the network, which can be large or small. Here's an example of a very small network. It's just a demo case. And now with those particular devices, the software can handle that. Since it's software driven, it's not expensive controllers and things. So that helps with kind of smaller install, being able to be very cost effective. Because it is software defined, then it can scale out to very large installs and really maintain pretty much the exact same architecture for how you think about a small or a large install. So that helps just from the complexity of the design. And then different kinds of devices that can be attached. Once again, these different devices, so this is an analog device, this is a dry contact device for a light switch. And the node that we have allows for connecting those different kinds of things. And so you can take a fairly inexpensive, if you look at all the different devices that exist for buildings today, 95% are not IP devices yet. And so if you can tap into those that already exist and just connect a node up to it, and now that device becomes a Power over Ethernet device instantly, that is a huge advantage. And we personally make it so simple that you just have some software, you choose the make and model of the sensor or device that you want to connect to this node, and it automatically configures the node to understand 0 volts to 10 volts equals 30 degrees to 70 degrees, or whatever that equation is, and it makes it that simple. So it's all about, kind of see a theme actually, it's about simplicity, it's about breaking down complex things. Yeah, we should pass this around. Breaking down complex systems into bite-sized systems that are plug-and-play components. So on the hardware side, you have the PoE switches. So basically just thinking about all the different components here. You have PoE switches, which is kind of buried inside this box right here. And then it could also be mid-span, so you can choose whatever switch you want. It doesn't also have to be a PoE switch. You can choose a non-PoE switch and put what's called a mid-span, and it just injects power over that Ethernet line. So it's more flexible. You can choose whatever brands you want at that point. And it's standard IP and IT type of equipment. So it's things that for maintaining cybersecurity and best practices for implementation of networks, that all of that domain knowledge of IP networks that are well understood. IP networks have been around forever and used at the largest scale, the most sensitive sites in the government and elsewhere. So you know that it can handle what you need, but also, unlike other protocols, which the physical layer is really tuned for that particular protocol. So if it's for lighting, you might hit mesh networks for Zigbee or something. Well, now those they can respond quickly, but they can't send much data. So now you're constrained to, I can only use it for lighting, but not much else. Or a network that isn't necessarily fast, like let's say BACnet, but it can service a lot of different devices. So there's all these different constraints, but the nice thing about IP networks is it satisfies all those, and then it's more of, it can have multiple protocols that are happening over that network. So I'm probably getting a little too technical here, but I'll try not to. So on the software side, we'll do a demo of this. It's really designed to service, once again, an unlimited scale of different devices. This is an example of a dashboard that sits up in the cloud, that we do pull all the data so that we're in 27 different countries, and one of the ways that we can really maintain a strong brand presence in all of these areas is that this data is sent up to us. So if anyone's ever having a problem with install or operation or anything else, we can log in and provide tier 2 support by looking at that data more effectively than most can provide tier 1 support locally. When you plug in a device, and you'll see this in the demo, but it quickly just recognizes that device. As soon as you plug it in, the node will announce itself over the network, and the gateway software recognizes that, and it shows up, and you can see, this is something that's online, this is something that's offline, but just a very simple way of just plug and play. You don't have to sit there with addressing or configurations of any kind. It's just plug it in and it works. If you get a node that is by itself and you need to configure it for whatever you're attaching to it, then you do have to do some configuration. If you're getting the node from someone like Hubble, where it comes prepackaged as a Power Hub enabled fixture, well then the node is already configured for that particular device, and it's just all plug and play. So some of the major advantages of the node, there's other Power over Ethernet systems out there, but the things to really be focused on is that it's simple because it's easy to configure. Once again, it's daisy chaining, so on that node that was being passed around, you'll notice that there's an input for Power over Ethernet and an output for Igor, so you don't have to have a home run to every single little thing, but instead you can daisy chain and get as many devices, especially on 100 watt per port, get as many devices as possible. So it's very versatile. It can connect up to a number of different devices. This is actually our latest node. It does 99 watts, and it has USB as well as RS-45 serial. And so I'll let you pass this around. But where this allows us to go is, imagine if there's a USB port everywhere in your cylinder. So today we're really constrained on proprietary protocols and serial buses and things like that. But if everyone has USB devices, there's lots of USB devices that already exist in the world. So to be able to just go and connect up a USB device to a nearby light, I think is hugely transformative. And that Power over Ethernet network is the foundation to be able to do those kind of things that have never been able to be done before. And obviously IP security is a big point. I'm actually on the UL cybersecurity task force for IoT. So it's something that is pretty dear, that this has a lot of strengths. I had a previous company that I started right in college that I've since sold, and we did integrations with building control systems and see all this in a portal. And one of the sites that we did was the U.S. Capitol Complex, everything with the White House. And you can imagine, we had to go through DoD certification, and so those kind of lessons learned have been incorporated into this platform. So it's as easy to Igor enable something, take a device, connect it to a node, and now it's PoE. So it's really that simple. And a node can be attached to multiple devices. So it doesn't just have to be a one-to-one, but you can have a variety of sensors and lights and wall controls all connected to the same node if you want. The key takeaways is by utilizing standard Power over Ethernet equipment, now you're able to do things that you otherwise can't. And it's because it's standards-based, you can get this stuff from a lot of different sources that are well understood and well-known. It's not a proprietary system, it's an open system, it's using open standards. And that allows for all the benefits for security and scalability that have already been in the Ethernet world. And because everything's moving to DC, once again, above the waist, everything's pretty much already there as a DC device. Why not utilize a power supply, and everything's moving to becoming more data-centric. So this is all that, all consolidated in one cable, and it just makes sense. So interoperability, if we, how many people know about BACnet? It's pretty good. And BACnet is an interesting network. There is no security on it at all, and it's used for HVAC systems typically, and possibly other systems to talk to each other. But there's no security. It's all peer-to-peer. So when you have peer-to-peer, if someone gets on the network, they can see everyone else, and there's no real way to stop that from happening. One bad actor could really start compromising others. So there's a lot of issues with BACnet, and it was really not really meant to be on the network. It's gradually, everything's gone onto the network, so they just adapted that to be now network-based. So it didn't really have security and some of these other concepts in mind, and now it's just kind of grown to this point where these vulnerabilities exist. But BACnet's also extremely difficult to understand. If you're from the industry, if you've been doing it for a long time, then it makes sense. But if you're just a normal programmer and you want to start doing interesting things with integration, you have to have access to a BACnet network. You have to be able to experiment with it and so forth. And that's just a real problem. Not many people are going to let you start experimenting with the building. So that's also a kind of a barrier market for any type of innovation to occur on a BACnet network. And then even though BACnet is a word that everyone uses, there's slight variations between vendors, which makes things not as compatible as we'd all like. So instead, by having the central platform that, in our case, is the Igor platform, and then having connector services that can talk those specific protocols, whether they're smart lights or building systems like BACnet, and then other IoT devices that are already on the network that we can connect to. For instance, we're integrating with gunshot detection. So that allows all of that data to exist in one platform, and then because of the secure APIs, those can be compartmentalized, where you say, this particular connector has its own app key. So if you no longer trust this particular system, you can isolate it and orphan it off and basically quarantine it so that it's not interacting with all the other systems. So over time, what this does is allows for creating AIs and machine learning and so forth to analyze the telemetry data, because all this data is flowing from one device to the next. Right now, no one knows what's happening. If there's a bad actor, you don't really know. But if it's flowing through a system, then you can detect the shape and way in which these systems are talking to each other. And although this one sensor is really just being used in this one way, but all of a sudden there's this other device that shouldn't and never has started interacting with a sensor, then why is it doing that? Why is it hitting it a whole bunch of times and going off and doing things it never did before? So there's ways in which just understanding how systems work and seeing how they deviate from the way they have in the past, it really can help with cybersecurity. And ultimately, with IoT, right now it's just pretty much two systems that talk to each other. You might have a BACnet network, and maybe security. But with IoT, the diversity of systems is just going to explode. And so if you think about looking at edges, if you have 2 points, you only have one edge, you only have one connection to really have to worry about. But if you have 3 points, now you have 3 connections. If you have 4 points, 4 different systems, you have, it just exponentially goes up, right? So you have 6 different connections. So having a platform for the future is absolutely critical to understand and manage and have any hope of understanding what's going on or containing bad actors. This is just another way of representing this. You have a node, you can connect all these analog and serial bus or anything that's not IP-based. Anything that's not IP-based connects up to the node, you're powered by the node, communicates to the node, that then goes up to the software has the intelligence. These other third-party systems that are already on the network then connect the software, just create a microservice that's an integration to that particular system, and now it can communicate using that protocol. So that effectively, the software becomes that unifying platform that brings all these worlds together. It's kind of like the Lord of the Rings, it's the one ring bringing them all and binding them, right? So hopefully not doing bad things, but it's all up to you as to what you deploy in the system. And then you have those analytics. So kind of the takeaway here is the connected building platform that we're really promoting is an IT data-driven platform versus this peer-to-peer with proprietary protocols. Peer-to-peer when it's proprietary is a problem because now all those different systems on that network have to talk the same language. And even if they talk the same language, they may not behave the same way. So then you get weird things from different vendors sending the same command but behaving differently. So by elevating the intelligence to the software, now you can be more effective at the way in which these systems operate. Your simple RESTful API, so I was talking about backnet and the issues there. By using a RESTful API, which anyone that's familiar with programming is usually really excited about that. It's something that everyone can just jump into, no problem. And now you're able to, as a normal developer, start going to work and create. This becomes this innovation platform where, as an end customer, or we really see this third-party developer ecosystem emerging. We want to help cultivate that, and that is a key component. Just breaking down these barriers to get this, having a smart building become a collaborative environment where people can add value, whoever they are, to that building. Compartmentalized API, already talked about that, and then real-time API events. That's something that is pretty important for, obviously, lighting needs to be a real-time system other than a typical HVAC system or heat, ventilation, air conditioning. It could be 10 seconds or a couple minutes before it starts up. No one notices, but this has to happen instantly. All the lights have to turn on at the exact same time. They all have to behave in unison. So there's a lot of requirements, and this system is able to do that. And so all that benefit of being a real-time system at that level now can be applied to other types of sensors and devices. All right, so the value of data, this is all of that other stuff is really the foundation to unlock the value of data. So today, systems are limited, they're in silos, they do a specific thing, they're expensive because you have end-to-end effort on design and implementation and labor and everything for security, lighting, and so forth. And then it's really inflexible. Whatever it is day one, it's that way forever, and nothing changes. So trying to change that paradigm so that it can be something that it is more flexible is the key. So you can't analyze. There are systems out there where you get data, so then you can analyze. But a lot of times it's too expensive to adapt it because, and this was the issue with my last company I had. We were an analytics platform for buildings. We have all this great data. We know you can improve your energy savings 80%, but you had to do things that were so cost prohibitive, like even if it was just a configuration change, a lot of times it was complex enough with these systems that was too difficult and too costly. So you're really unempowered. And in today's world, as we all know, business is either moving forward or all your peers are, and you're staying behind, and then you're going to just get lost. And so you're either adapting and evolving as a business, or you're not going to survive. That's the same thing with every aspect of a business. So your building is just an environment that should be something that encourages the outcomes that you want for a business. So if you're retail, it should be an environment that's encouraging sales per square foot. If it's a school, it should be encouraging safety and higher learning capabilities for the students. So every vertical, every customer has their own outcomes that they really want. So, and then on top of that, you have IoT, which there's new things happening all the time, and innovation is only going to accelerate from this point forward. So how do you have something that you can insert into your building day one, or it could be later as a retrofit, but that can continue to change with you over time and be a foundation that will allow you to continue to adapt and not be constrained. So in the world of programming and other types of design, talk about lean and agile, and those terms are really important. That's what we are as a development organization ourselves for product development. And it's all about what do you want, do things, what are all the things that you love to see, and all those features, and then focus on prioritizing it and just bite off a few of those, the high priority ones that you see, and then deploy them in more of a bite-sized way, experiment. So once you have this platform in your building, let's say you want to implement gunshot detection, or we want to want to use motion sensing and Bluetooth to know authorized motion. So when you have motion, if there is a certain beacon, Bluetooth beacon, hey, this motion isn't authorized because there's not someone here that I recognize. So if you can do those kind of things and then see what was the impact. Well, did this matter or not? And maybe it was a complete failure, you have no interest in pursuing it and scaling it out. Maybe it's something that you need to change a little bit and try it again in that small way. Or, hey, it's a success and you scale it out. But instead of having these capital projects that, as a stakeholder at a company, that you're only able to do a few things a year, instead you can do many more things a year, get a better idea as to the results, and then know what's worth scaling and what's not. So the desired outcome for being lean and agile is you lower the risk, you lower the cost, you get more information, you're able to increase that iteration cycles and innovate faster, and you're effectively going to be empowered against your competitors so that your building, once again, is really promoting the outcomes you want. So if you're able to be a senior center that's able to detect falls more easily, and you're able to help people when they get out of bed in the middle of the night, call the nurse call, you're able to see how often did someone go to the bathroom in the middle of the night, because you have motion sensing as well as the bed sensor, and you take all that data and then you feed that to the patient record system, and you can find out based on their baseline they only went to the bathroom 3 times a day or night, but now all of a sudden they're going 10 times for twice as long. Well, urinary tract infection is one of the major issues in senior living. So those are all things that you can start iterating this innovation and set yourself up to be a leader in whatever space you want. And so this is the user interface that's hosted locally. And so this is a local interface that's hosted locally on actually this machine, but if this was a large install, then it would be on a server somewhere in a rack or whatever. And so what we have here is we have individual spaces that are on the left side, and of those spaces I can click on manage, and now I see what are the different devices that are in that space. And so this particular wall control button is powering those 2 particular lights. And actually I think it's this wall control button. So you can see how it's doing that easily, just as you expect. But if I remove that wall control now it doesn't operate as you'd expect. So it's just associating things into a space, and they just work as you'd expect. And just plugging things in to the Ethernet, they'll just show up in a matter of seconds. You kind of see that Knight Rider, scanning happening, and that's what it's doing. It's just actively scanning, and as anything new shows up on the network, you'll be able to see that, and then just attach it to the space. So I can put that back in the space. If I want to see, well, what particular light is that? We have a number of ways of doing that. So this is one where I want to flash it, and now I know what light that is. If I want to see, well, which particular wall control is that, I can put that into ID mode, and now, if I hit this much times, well, it's not doing anything, so it must not be that one. If I hit this much times, then you can see that number just went sky high, and so it's the wall control I think it is. And now I can rename that. So there's a number of things that we do. We also have a mobile app that you just walk around and just, it's almost like makes a game out of the installation of the commissioning process. And so lots of easy ways to make commissioning and install simple. And that's, once again, a major theme of who we are. It's about creating simplicity. If I go into any one of these devices as well, if I go into this particular light and I click on it, I get a lot of detail on it. So we try to keep it simple as to what information you see, but you can see a lot of information, and it gives you the ability to really understand what's going on. Also, if I go to, let's say, this chain, I can see there's only one node on this particular daisy chain, but it has this particular IP address and this particular MAC address, and if it's hooked up to a certain kind of switch, I can know, like a Cisco switch, I would know exactly what port and what switch that particular device is attached to. And I can even click on the node, find out information about that specific node, what devices are connected to that node, how much power draw is happening on those devices. So it's very thorough. All this data is also available via our API. Our API isn't just giving you a subset of capability, it provides everything that you could possibly want. So our entire user interface uses our API. If I go back to action sets, actually if I go to spaces again, so it's all about just associating things to each other, or to a space, and then that acts as a container, and then we have policies that you set, and based on those policies, you can either do it at the space level or space type. Let's say all hallways operate this way, or you could even do it at the individual light. But those policies really dictate how it behaves, and that by doing those two things, just associating things and setting policies, it's that simple. And then you also get that real-time feedback, so as you're operating things, you can see what's going on. There we go. So you see that information coming through. Action sets, there's all kinds of things you can do there. Actually, one of the more interesting things is the wall controls. If I go to wall controls, so these are a way of defining action sets. I can do basically animations or scenes where I have those particular 3 buttons on that wall control. I can say not only when I press it does something, but I can add gestures. So because we're software defining this wall control is just a dry contact. It's not intelligent, but because we can add intelligence to our software, we can say, well, what happens when you hold it, or if you do a double press? So if I go into one of these, I can get very specific and add a whole bunch of actions and change the timing between actions and create, kind of like a bat cave where in Dark Knight, you see the lights turning on in an animated way from the room. So it's just really interesting, cool things. Our software operates as a whole bunch of microservices instead of one behemoth service. That makes it so that not only are we breaking things down to plug and play components physically, but also on the software we've broken it down that way. So it's easy to add new services and be able to communicate to new protocols and expand the software. And so these are all these different services that are running. It's not all the ones that we provide, but it's easy to go in here and see the bindings and configure it for different IP addresses and things like that. So it's very robust when it comes to, once again, that cybersecurity aspect, and from a network perspective, it's very helpful. It also connects as a firewall between the outside world and the IoT network by having that capability. A couple last things, this will be it. So one thing is being able to add an API key. So let's say I just want to have a system called LC4, and now that's my key, and I can utilize that for sending commands, but every integration can have its own key, so it's, once again, very compartmentalized for the security. And we can also have webhooks, which gives us instantaneous feedback if any events happen on the system in real time. But let's go back to now the API, and this shows you all the things that you can do within the system if you're a programmer, if you're an integrator. If I want to do something with lights, for instance, I can open that up. I can see all the different things I do with lights. And if I want to get a list of lights, that's that top one here. And so if I click on that, then I can see exactly what the data would be. And then I can even try it out. It says, well, sorry, you need to enter an API key at the top. So I can go ahead and do that. And then you'll see that it's really, now we're operating in the context of that specific API key, that particular app. So when I say try it out, it works, and I get all the data that is pretty extensive for those particular lights. So lots of ways in which you can use, once again, this becomes an innovation platform that is really open, allowing just about anyone to be able to do whatever they want on it. So that's really, our goal is to empower people to get the most out of their buildings. So with that, any questions, and thank you for your time.